So in this session, we are going to talk about the difference between distance and displacement. These topics are covered in the class 9th, and apart from this class, they are also taught in the class 6th and 7th as well. But we will cover it in a way that these classes will be covered and class 9th will also be covered. Clear? So without any further delay, let us start the session. So before starting the session, this is about me. My name is Nadeem Hafiz and I am physics master teacher at the sisyaclass. I have done BTech in civil engineering and I have over 5 years of experience in teaching. So let us start the today's session. So as you can see that the difference whenever you are writing the difference, okay? So write one from the one side, from the left side and other from the right side, and there should be one line in between these. Okay? So don't write the difference in the paragraphs. Clear? So I keep the so there is one point on each slide. Okay? As you can see, let us start. So when we talk about distance, let's suppose a body is moving, okay, from point A. Okay? So the body is moving in certain direction. Let's suppose in right direction like this. Okay? Then after this point, okay, after reaching to this point, the body turns. And let's suppose the body covers some distance, okay, or some distance it covers, okay, certain meters. For example, here it covers 10 meters, here it covers 20 meters. Now, this point, this body reached to point B. Got it? Now, what is distance? Distance is the total length the body has covered. Okay, the body started moving from point A, okay, and it reached to the point B. So it covered some distance, yeah, it covered some length. And what was that length? First it covered 10 meters, then it covered 20 meters. So this total length the body covers when it goes from a certain point, which is called as the initial position, to the final point, okay, which is called the final position. Got it? So that's the definition of distance. That the complete length of the path between any 2 points is called distance. Got it? And if I tell you what is the distance in this case, this would be very easy. See, distance would be equal to 10 meters plus 20 meters. And the total will be 30 meters. Got it? Very good. Let us see the displacement now. The shortest distance between the initial and the final position. Okay, let's take an example again. A body starts moving from point A in a certain direction. Okay, so body is moving. Okay, it covers a distance of 30 meter, for example. It reaches to certain point. Okay, then at this point it turns around. Okay, it turns around 180 degrees. It turns and it's coming back like this, to this point. Got it? Yeah. And this point is on the same line like this. And it covers 20 meters. Fine. Yeah. Okay. So let's name this point as B. Done. Now, in case of distance, if I tell you what is the distance covered. So first this body covered 30 meters. Then the body covered 20 meters. So the total distance, okay, total length it covered is 50 meters. But what about the displacement? It is the shortest path between the initial and the final position. Which is our initial position A, which is our final position B. See the shortest distance, shortest path is always the straight line. So as in this case, it will be this much. Yeah. Okay. And how much this will be? Yeah, it is 30 minus 20. So it will be like this: 30 meters minus 20 meters is equal to 10 meters. So what is the displacement here, my dear students? Yes, it is 10 meters. Done? Very good. So this is the difference number one between distance and displacement. Got it? Very good. Let us move to the second difference. To calculate distance, the direction is not important. Okay. As you saw in the previous example which I took. See, 30-meter was towards the right, 20-meter was towards the left. Okay. But I did not care about the direction when I was calculating the distance. Okay. But when I was calculating the displacement, I did take the direction into the sense. Yeah. Very good. So in case of distance, to calculate distance, direction is not important. And tell me, what kind of quantity is that wherein the direction is not considered at all? Yes, obviously, that's called as the scalar quantity. Yeah. So distance is a scalar quantity. And my dear students, when we talk about displacement, to calculate displacement, the direction is taken into consideration. So direction matters a lot. So in that case, it is called as the vector quantity. Got it? Okay, that's nice. So distance is a scalar quantity and displacement is a vector quantity. Got it? And one more thing. Distance you usually represent, okay, distance, I just add this point, distance is represented, okay, is represented by d, okay, and displacement on the other hand is represented, okay, by s. Got it? And it's a vector quantity, and you know that when we represent the vector quantities we put an arrow on the top. Okay, that's nice. Very good. Let us move to the next difference. Distance can only have the positive values. See, if a body is moving, it will cover some distance, it will cover some length. Yes or no? Obviously, if a body is moving, it will cover some length anyhow. Okay, so that is why the distance can only have the positive values. Okay, it can never have the value 0, okay, if the body is moving, and it can never have the value negative if the body is moving. But on the other hand, displacement can be positive, it can be negative, and it can be even 0 as well. Okay, so there is one thing we can deduce from this, and what is that? Let us see. For a moving body, okay, for a moving body, for a moving body, distance, yes, is always greater than or it will be equal to displacement. Yes, distance is always greater than or equal to displacement. Got it? It can never be less than displacement. That you should know. Why? Because see, displacement can be 0 as well. Displacement can be negative as well. But distance will always be in positive. Got it? Very good. We will see some questions on this. Now, distance. Distance depends upon the path. That is, it changes according to the path taken. Obviously, for example, if a body is moving, okay, first it covers some distance, then it turns, okay, then it covers some distance again, yeah, okay, then it covers some distance again in this manner, yeah. Now you would see that, let's suppose it covers 10 meters here, 10 meters here, 10 meters here, and the 10 meters here, okay. Now distance is, it depends upon the path which is taken. For example, I'm taking this path right now, okay, between point A to point B. Now, what will be the distance between point A and point B? Yes, it will be 10 plus 10 plus 10 plus 10. That means 40 meters. Okay, 40 meters. I just add them. So now if I move in some other direction, for example, I move directly from A to B, I'm saying, okay, directly from A to B. In that case, my distance would be what? 20 meters, isn't it? Yes, very good. So distance depends upon the path taken and it can vary. But displacement between the 2 points, okay? displacement between the 2 points. It will not change. Okay, path can be anything, but displacement will always be the same. So that's what it is writing. Displacement does not depend upon the path. It only depends upon the initial and the final position of the body. So in this case, for example, from A to point B, okay, from point A to point B, displacement will always be 20 meters. Okay, that's nice. So now let us move to the next. Okay. Now these were some differences between the distance and the displacement. Now let us solve one question on it. Now the question is saying a body travels 2 kilometers towards the east. Okay. That's nice. So it covers 2 kilometers towards the east, and we know that if we do not know the direction, this is how you go for it: north, south, and then you go for west, and then you go for east. Okay. Now a body covers 2 kilometers towards the east. That's it. Yeah. Then, after it turns right, okay, and covers 3 kilometers. So from this point, it covers 3 kilometers like this. Done? Yeah. Now you are asked, so this is the final position now. So let's suppose this is point A, this is point B, and this is point C over here. Okay. Now, you don't need the direction here, okay, because that's already done. Now you need to calculate the distance. Okay, distance would be very easy for you. You are familiar about the distance. Would be equal to what? It will be first 2 kilometers, yes, then plus 3 kilometers, isn't it? So 2 plus 3 is how much? 5 kilometers. Done? That's absolutely great. Now let us see the displacement. Okay, let us see the displacement. Now displacement is the straight line, okay, shortest path between the initial and the final position, isn't it? So this is what you will do. You will draw a straight line between these 2 points, okay, and you would see that it is forming a right angle triangle, isn't it? So you can use what? You can use formula. Which formula you can use? Yes, exactly. Hypotenuse square equals to perpendicular square plus base square. Yes. So here AC AC square equals, because AC is the hypotenuse here, okay, equals to AB square plus this AB square plus BC square. Clear? Done. AC will be our displacement. Okay, so AC will be equal to under root of AB square. AB square is how much? 2 square, isn't it? Plus BC is how much? 3. So it will be 3 square here. So AC equals to square root of 2 square is 4 plus 3 square is 9. Okay, 9 plus 4 is how much? 13. Is it? Yeah, 13. Root 13 kilometers. Okay, so there we go. What is the distance? It is 5 kilometers. And what is the displacement? It is root 13 kilometers. Did you get it? That's very nice. Now, there is something which you can write. You can write it like this: 13. How can you write 13? No. Okay, you can't write it. That's fine. Okay, so otherwise, for example, there are some numbers which you can simplify, but here you keep it like this. So distance is 5 and displacement is equal to square root of 13 kilometers. Got it? Okay, I hope you understood the difference between the distance and displacement. We applied it in one question also. Okay, so for more further lectures, stay tuned and subscribe to the CISIA class. Bye, take care.